Hello, grade 8 math. This is lesson 6.7, graphing linear relations. To start off, I want to review a little stuff, a few of the things we did last year in grade 7. The first one is we know about ordered pairs now, and essentially you've got your x coordinate first, which in this case is 4, and right here, this second one is 2. And the second coordinate, 2, is the y coordinate. So remember our graph, moving left or right is x, and moving up, down is y. So if you notice from the center, we move 4 to the right, and right is positive. That's why this is 4, and we're in line with that. And then we moved up 2, and we are in line with the 2, and that's why this is 2. What about this dot over here? This is B, point B. Well, moving left and right, we move left 3, which is -3, so our first coordinate is -3, and then we move up 3, which lines up with 3 here, which is +3. So remember, these numbers that are vertical here are measurements of the second, and the ones that are horizontal here are measurements of the first. What about point C? Well, we move left -2, so the first coordinate is -2, and then we move down 2, which is -2. Notice that this point is on the lines that line up with -2 and line up with -2. Just to backtrack, B was in line with this line that is -3 and also this one that is 3. A is in line with this 4 and it's in line with this 2. That's why it's 4, 2. And finally D, well, we moved over 2 to the right, but we didn't move up or down, so we use 0. Now, you can actually make graphs a little bit different by scaling them differently. I'm going to zoom out a bit here. The difference between these two graphs is that I've scaled the y values a little bit differently. Rather than every box being 1, I've decided that I'm going to count up and down by 2s. So instead of this being a 1, I've made this a 2, a 4, 6, 8, 10, and then down -2, -4, -6, -8, -10. They're going up and down by 2. So I want to transfer these 4 dots that I had over here onto this one and just show some things here. Well, A is going to be 4, which is right 4, and up 2. So that's where A is. Notice that when the scale is double, the amount that it moves up looks like half as high, right? What about D? Well, it's over 2 and doesn't move. Well, it's in the exact same spot. What about C? It was -2, -2. Notice it looks like it's moved half as much down. And B, well, we move over -3, but where do we go for 3? We don't have a 3 on the scale. Well, 2 and 4, what's halfway between 2 and 4? It's 3. So we have to go to -3 and then up to this point that's exactly between 4 and 2, which that would be B. Okay, I've also drawn 2 other dots on here, point E and point F. Look at E. It's gone over right 1, not quite 2. It's halfway between the 1 line and the 2 line, which means it would be 1.5. And then if you go up, it's halfway between 8 and 10, which halfway between 8 and 10 is 9. What about F? We move over to the -2 line, and we've moved down halfway between -8 and -10, which would be -9. So that would be those points. So this is a little review of what we did near the end of grade 7. Just placing these ordered pairs onto the grid. You're going to need to know how to do that, as well as look at grid and come up with the coordinates. Here is an example problem. It says a grade 8 class is going on a field trip. The bus has 24 seats for students. So in this question, we're not going to worry about the ones for volunteer, parents, and teacher, and the bus driver, just students. And it says an equation that relates the number of boys, students, 2 girl students on the bus is, well, most of the questions in this unit you won't actually have to come up with the equation, but you guys actually have the skills to this. Let's think about it. What would the number of boys be equal to? Well, it would be that 24 students, and it would be subtract any of those students that were girls, right? It would be subtract the girl students, where G is the girl students and B is the boy students. In the same way, girls would be equal to 24 subtract B. So either way you look at it, I'm going to go with B equals 24 subtract girls. Boys equals 24 subtract the girls. Now, let's create a table of values for the relation. So using some of the stuff we learned last lesson. So if we have our girls, what would our boys be equal to, right? Our boys is equal to 24 subtract girls. Let's remember that. So let's say we have 0 girls. Well, 24 subtract 0 would be 24. What if we had 1 girl? Well, boys would be 24 subtract the 1 girl, which would be 23. What would 2? I think some of you are realizing this one's a little bit simple, but 24 subtract 2 would be 22. And eventually we see a pattern. Some of you might have seen it already. 24 subtract 3 is 21. You'll notice that this is just going down by 1, right? While this is going up by 1. So this table could continue for a while. And you maybe get to, what if girls is 23? Well, if girls is 23, 24 subtract 23 is 1. And what if girls is 24? Well, then there'd be 0 boys on the bus. What you'll notice about these linear relations, which this is one of them, as one of the variables goes up a consistent amount, the other will go up or down a consistent amount, okay? They're going to be a ratio between them. As this goes up 1, this goes down 1. Or some of them it'll be when this goes up, this goes up. Some of them will be when this goes down, this goes down. Or this goes down, this goes up. But it's going to be the same amount each time. Kind of like this is positive 1 and this is negative 1. The next thing you'll be told to do is to graph the relation. Now, I'm only going to use this much space to do this. Okay? And I'm going to think, looking at this, do I have any negative numbers? No, I'm not going to have a negative number of boys or a negative number of girls. They're not like suddenly just not there and like taking up a negative space. Like it doesn't really make sense. In this case, they're all positive. So I don't need to do one of these graphs like up here where we've got the negative side. I can just use this quadrant up here with positives. And then I need to think from my table, well, what values do I need it to go up to? The girls could be as high as 24 and the boys could be as high as 24. So I need to make sure that what my number goes up to, I can fit up to 24 on it. And I also need to make sure I'm going up by an exact amount. Now, I only have so much space here. I don't have 24 squares tall, so I can't have every square being 1. So maybe I need to make them 2 or 3 or 4. We'll need to figure that out. I don't like doing 3 because I can kind of split a square into thirds if I need to be between, but I like doing halves and quarters a little bit more. I think that it's a little clearer for me. So let's start by just drawing our lines. I'm going to just draw this like so. Then I'm going to do a little counting. How many squares do I have here? I have 1, 2, 3, 4, 5, 6, 7. So thinking about that, what could I go up by? If I went up by 3s, I'd have 3, 6, 9, 12, 15, 18, 21, which isn't enough. So maybe I need to go up by 4s. What if I go up by 4s? 4, 8, 12. 16, 20, 24, 28, which is more than we need. We need to have more. So let's go up by 4s. Let's go up by 4s. 8, 12, 16. Notice I'm numbering the lines. 20, 24, 28. So I've decided that each square is going to be 4. So if it's 1, I'm going to be quarter of the way up. If it's 2, it's halfway up, so forth. The next thing I need to do is go to the right. Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I could do 11 over, which I could get to 22 if I went up by 2s, but I need it to be up to 24. I could go up by 3s and I could get up to 33, which would be good, but then I'd be splitting by thirds and that kind of looks a little choppy. If they're pretty close numbers, my suggestion would be to just go up by the same amount if you have a similar length here. So I'm going to do that. I'm going to go up by 4s. 8, 12, 16, 20, 24, 28, 32. I'll fill those in anyways. And then all I need to do is start plotting these points. And we're going to see a little nice pattern. I'm going to use a different color for my points so that they stand out a little bit. I'm going to use green. So next thing is to determine which is going to be my boys part of the graph and which is going to be my girls part of the graph. And I've decided that the left-right is going to be my girls. Why? Because that's the one that I kept constant first, and it's the boys that's being calculated. So I'm going to have girls be the base here. So G is going to be this, and boys is going to be this one over here. So girls, when girls was 0, what was boys? Boys was all the way up here at 24. When girls was 1, which is a quarter of the way over, so not halfway, it's half of a half. Where was boys? It was 23, which is right up here. What about when it was 2? Girls is 2, boys is 22. 22 is halfway between 20 and 24, and 2 is halfway between 0 and 4, so it has to be right in the center of the square. What about 3 and 21? Well, girls was 3, boys was 21, which is a quarter of the way up. It's going to be right here. What about 4? Girls is 4. If I had more of these, I'd know that girls is 4. That was when it was 20. Let's do these ones down here. When girls was 24, boys was 0. When girls was 23, boys were at 1. So it's going to be right here. And what we're going to notice is since it's a linear relation, if I take my ruler and place it on these dots, it's going to be exactly in line with all of them. So where would we expect the rest of the dots to be? We'd expect them to be, on these places where the coordinates cross. Think about it. When girls is 8, boys would be 16. What's 8 plus 16? It's 24. Notice all of these add up to 24. We'd expect that. We'd also expect it to be on all of these spots in the middle of the squares. As well as the quarters of the way across. And once I've graphed all of these, there is my straight line that is my linear relation of boys to girls. Girls to boys. You may also get asked to describe the graph's relationship between the variables. Well, looking at this, every time you move up with the girls, the boys moves down, right? Every time it moves up 1, it moves down, up 1, down, up 1, down, up 1, down, so forth. So when girls increases 1, boys decrease 1. All right? As well, another thing we notice is that the points begin and end at 24 on each axis, right? When I say axes, I'm talking about the lines where x is 0, and y is 0 and where x is 0. So notice that it goes 24 to 24, which makes sense because there can only be 24 students on the bus. Here's another example. It says here there's an equation, and this is a linear equation. If you have y is equal to an x and maybe some other things, you're going to have a little linear equation here. First things first is to create a table of values, and often in the assignment it'll tell you from like -4 to 4, so all the numbers between is what you will make your x equal to, meaning the variable here that's with the numbers. I'll give some guidelines for the assignment when it doesn't specify after. Sometimes you will do 0 to 5, and other times you'll do -3 to +3. It kind of depends the context of the question. But this one, it's specifying. So we're going to do from -4 to 4. So what we're going to do for a table of values is you grab x, you make y, which we know y is equal to -4x plus 1, and we draw a line between, draw a line across, and where x is going to be -4. What's the next one? -3, -2, -1, 0, 1, 2, 3, 4. Now, this sometimes confuses people because often you do, with the tables, you go negatives at the top and they go down to the positives, whereas on the graph it flips. I'm not sure why that's the convention in math, but I thought I'd mention it so that you don't get mixed up with it. The next thing you need to do is figure out some of these math things. My suggestion is to do the calculation for 0 first. Why? Because when x is 0, this coefficient doesn't matter because anything times 0 is going to be 0. All this one here is going to be your constant, right? Remember, where x is 0, whatever's being added or subtracted here, that becomes your thing. So if it's +1, it becomes 1. When it's -1, this is -1. Okay? Next thing, I like to do 1. Why? Because -4 times 1 is super simple. Anything times 1 is just that number, so -4. I'm going to draw this in here. Okay? And I'm going to just keep my answers on this left column, so what I come up with at the end, I'm going to write down here. Remember that y is equal to -4 times x, which is 1 in this case, plus 1, which is -4 plus 1, which is -3. So this is -3. What about 2? Well, do the calculation again. -4 times 2 now. Why? Because it's -4 times x plus 1. Add that 1. -4 times 2 is -8 plus 1. Becomes -7, so we'll write -7. At a certain point, you're going to start seeing a pattern. And what I'm seeing here is a little pattern where this just went down 4, this went down 4, which means the next one I'd expect to be down 4. Let's see. Let's see if this becomes -11. Let's do the math to prove that this pattern works. Once it happens 2 or 3 times, it's going to continue. -4 times 3 is what our x is, plus 1. -4 times 3 is -12 plus 1. -12 plus 1 is -11. Is that what we predicted? Yes, it did. It was. So let's do that again. -4 going down will become -15. And we could do the calculation, but why do it when we've seen the pattern? Now, that means that from this one down will be -4, which means going back up will be adding 4, right? So we'd expect this to be 5. We'd add 4, we get 9. Add 4, we get 13. Add 4, we get 17. What I like to do is do my end value just to check that I didn't make a mistake. So I'm going to do this. -4 times -4 plus 1 equals, well, -4 times -4 is 16. Remember, negative times negative is positive. Plus 1 is 17. And yes, that's what I got. So if this one's right, then I'm assuming I did it right on the way up. So if you follow the pattern, it's -4 as you go, increase this by 1. Every time this increases by 1, right? This one here decreases by 4. So that's the relation here on the graph. We'll talk about that at the end. Let's graph this. So we're going to use these values here and we're going to graph it. And we only need to graph from -4 to +4, which I like to keep my graph here. Part B says to graph it. Okay. I like to keep the side to side going by ones. So if I have -4 to +4, I'm going to need 8 squares wide. So wherever I draw this, I'm going to go right here. I'm going to go 4 and 4 more. And I'm going to draw a bar through this. I have lots of space up above and below. Let's see. My biggest y value, so how far up it's going to go, is going to be 17, and my lowest is -15. Okay? Let's just draw in my x-axis. Draw in my y. After. Let's think about it. I've got 1, 2, 3, 4, 5, 6, 7 here, which 7, if I went up by 2s, would go to 14. 2 times 4, 7 is 14. That's not enough. What if I go up by 3s? I could get to 21. You know what? I'm going to go up by 3s this time, which means I'm going to have to split these squares into thirds, but I'm going to do it just to show that you can. My preference normally is to not, just because I personally don't like splitting it up into thirds, but you can. There's 21, and so then you go down by 3s, -3, -6, -9. Notice that these are the same numbers, just -15 and -17, 18 I meant to say, which that has enough there. So I usually set it to the side that is the bigger number. So looking at our values, I had 17, which is a bigger absolute value than 15, so I set it to 17 to make sure I had space. Some of your values, you'll have one side is like really high numbers and the other one's like barely below 0 or whatnot. You need to adjust this line up or down based on that. So let's graph this. Our first value, you know what, I always like starting with 0. I don't know why it is, I just find it easy. So where x is 0, it said y is 1. Now, this is 3, so we need to split this into 2 and 1. It's got to be right here, right? What about where x was 1, y was -3? So find x is 1 and move down to -3. Well, that one's right on the coordinate. That makes it easy. X is 2, -7. Where x is 2, it's -7, which is a third of the way towards -9. What about where x was 3? It was -11. So -11 is down here. Now I'm going to show you something cool. To save some time, once you've got a few points, connect the dots. If they're all 4 of these are on the line, we're going to have a pretty easy time putting the rest of the dots on here. Okay? Why? Because all you have to find is all of these up-down lines, find where they touch the ruler, and place it down. Now think about it. 4 here and -15, are those the dots? Are those the coordinates we calculated? 4 and -15. Voila! Look at that. Voila! It lines up perfectly there. What about this line? Sorry, I have it a little bit off. Where was I? Oh yeah. Let's place that there. Well, we'd expect this to be right here, which would suggest -1 and 5, which if you look at your chart, it is -1 and 5. What about -2 and 9? Is that the chart? Yes, it is. Let's place this here and place this here. Let's check these. -1 and 5, -1 and 5. -2 and 9, -2 and 9. -3 and 13, -3 and 13. -4 and 17, -4 and 17. Look at that. Because this is a linear relation, if you notice a linear relation, you're able to predict what points will be further without even having to do all this math in here sometimes. So if you have a small section of it and you prove that pattern continues, you can assume that pattern is going to continue indefinitely. And that's why graphs are so important for showing data. You can graph it out and you can extrapolate, you can spread it out further than what the graph says, and you're able to find out what the points would be off the graph. And part C of a lot of the questions will say, describe the relationship of the variables on the graph. Well, I'm going to use another color again here. Let's use pink. Notice that when we take x and we make it plus 1, this y value goes down from 17 to 13. 17 subtract 13 is 4. It goes down 4. Notice again, move over 1, it goes down 4. Move over 1, it goes down 4. That pattern continues. If it's a linear relation, it's always going to have that same sort of stair pattern there. I'm going to zoom in on that just for a moment so it's a little clearer. Negative 1, or sorry, when you go up 1, it goes down 4. When you go up 1, it goes down 4. Up 1, down 4. What about if you go the other way? What if you go down 1? Well, it's going to go up 4. Notice that they're the opposite signs in both cases. You could look at these either way, or you could go up 1. It goes down 4. Linear relations will always have that relation. So how would I describe it? I would say, oh, I tilted the camera a little weird. Describe the relationship of variables on the graph. I would say the variables when x increases by 1 or adds 1, I'm going to say increases by 1, y decreases, negative, right, by 4. And the line goes down to the right. Right? If you were to connect these dots on this graph and make it a line that connects, it would go from top left to bottom right. This is a sign that you have what's known as an inverse relationship, where these would be opposite signs. If it goes up to the right, from bottom left to top right, that would be one where you'd have the same signs. You'd have both positive or both negative. Whereas this, when there's opposites, that would suggest it's going top left to bottom right. That's a pattern that you'll see as well. And I'm going to say this here on your assignment. If it doesn't say, like, go from -6 to +6, or -2 to +2, or 0 to 7, if it doesn't say, what you should assume is go, if negatives aren't possible, like negative x doesn't make sense, like negative people or something like that, do 0 to 5, to +5, should say to 5. But if negatives would be possible, like it kind of makes sense, do -4 to 4. So that's just a little guideline on your assignment. Show the calculation a couple times, and then if you see the pattern forming, then continue that pattern. You don't necessarily have to show it for every single calculation if it doesn't say to. One tip, do what we did here in this assignment, where you do create a table first and then make a graph from it. And another reminder of what we did, make sure you have enough room on your graph that it fits, but don't make your graph so huge or so small that you can't even tell the difference between the points. Make sure that it's something you could actually see pretty well.